Hey everyone and welcome. Today we are diving into something that is absolutely critical for anyone working in modern software. We're going to talk about how to stop drowning in raw data and start turning all that system telemetry into actual powerful intelligence. So, let's jump right in.
You know, this quote right here, it just hits the nail on the head. Every single one of us has felt this pain, right? You've got logs, traces, and metrics flooding in, but trying to figure out what's actually happening feels like listening to pure static. It's just noise. And today, we're going to figure out how to find that signal.
And that noise? Well, it has a name. It's inconsistent data. This is the real villain of our story. It's the reason why a simple debugging session can turn into an all-night nightmare and why our super fancy dashboards sometimes don't tell us a thing about what's really broken.
Okay, so this lays it out perfectly. On the left, you see all the stuff that drives us crazy. Telemetry that's all over the place, root cause analysis that takes forever, and getting locked into one vendor's way of doing things. But look at the right. There's a solution for each one. Standardized attributes, spans that are packed with context, and a universal format. It all points to one big idea. We need a shared standard to make sense of it all.
And that shared standard is what we call semantic conventions. Honestly, the best way to think about it is like a universal grammar for all of our systems. It's the common language that lets our services, no matter if they're written in Go, Java, or Python, actually talk to each other in a way that makes sense.
So what is it really? At its core, it's just a set of standard naming guidelines for all your telemetry attributes. That's it. By just agreeing on what we call things, like an HTTP status code or a database name, we suddenly make our data consistent, predictable, and this is the most important part, machine-readable. This is the foundation for everything cool that comes next.
And boom, here's a perfect example. Look at the left. HTTP code equals OK. Sure, a human can probably figure that out, but for a computer, is OK the same as OK or OK? It's totally ambiguous. Now look at the right. http.status_code equals 200. It is precise, it's structured, it follows a clear pattern. This is data that a machine can instantly understand, query, and build automations on top of. It's night and day.
So, how does this whole universal grammar thing actually work in the real world? Well, it's not some giant single rulebook. It's smartly organized into these logical pillars that cover all the key parts of a modern tech stack. Let's take a look. First up, HTTP. You know, the language of the web. By standardizing things like the method, the route, and the status code, we can instantly understand every single user request that comes into our system. We know what they wanted, which endpoint handled it, and if it worked or not. Simple, but so powerful.
Of course, almost every request ends up hitting a database, right? So with these conventions, we get this incredible visibility into what's happening under the hood. We know if it's MySQL or Postgres, we see the exact query that ran, and crucially, we know precisely how long it took. This is how you hunt down those slow queries that are killing your app's performance.
But hey, we live in a world of microservices, so not everything is a direct request response. For all our asynchronous systems using Kafka or SQS, these conventions are a lifesaver. They let us trace a single logical request as it hops from a producer, through a topic, and over to a consumer. Without this, you're just flying blind.
And where's all this stuff running? Probably Kubernetes, let's be real. These attributes are what connect our application story directly to the infrastructure it's running on. So when something goes wrong, you don't just know the error, you know the exact pod, the node, and the container that it happened in. For debugging, this is a total game changer.
And finally, we have resource attributes. You could argue these are the most important of all. They give us the basic identity of whatever is sending the telemetry. What service is it? What version? Is this production or staging? Which cloud is it on? This is the context that lets us tie everything else together and see the big picture.
Okay, so we've set up the rules, we've got to grammar. Now, what's the payoff? Why does all this matter so much? Because this standardization isn't just a nice to have. It is the absolute non-negotiable foundation for turning all that observability data into real automated intelligence. This is how AIOps becomes possible.
Just follow the flow here. You start with an amazing tool like OpenTelemetry to collect everything. But then you add that secret sauce, semantic conventions. Suddenly, you're not looking at data anymore. You're looking at correlated insights. That lets your system start detecting patterns and predicting failures before they happen. And the end game? Automated remediation. Systems that can heal themselves. This is the future, and it all starts with that structured data.
And this is where it all comes together.
This is just one single span, one piece of work for a checkout process. But just look at the story it tells inside the attributes. We know it's the payment service. It was an HTTP post that was created successfully. It talked to a Postgre database. It published a message to Kafka, and the whole thing is running on AWS. All of that intelligence packed into one single event, just waiting for our dashboards and AI models to use.
So you see the power here. Now the big question is, how do you actually make this happen in your own world? Let's quickly run through a few key best practices that will get you on the right track.
First off, just stick to the official conventions. It's going to make your data ready for all the cool AI tools of the future. Second, don't go making up your own custom fields unless you absolutely have to. Every time you do, you're breaking that universal grammar. And finally, let the tools do the work for you. Use the automatic resource detection in your SDKs to fill in all that cloud and Kubernetes info automatically.
And that really brings us back to the core idea of this whole explainer. It all boils down to this one simple truth. Telemetry without conventions? It's just data. But telemetry with conventions, now that's intelligence. It's structured, it's correlated, and it's ready for some serious automation from the second it's created. So I'm going to leave you with this one question to think about. Take a good hard look at the telemetry your systems are producing right now. Is it just a massive sea of disconnected data points? Or is it a rich source of structured intelligence that's ready to power the future of how you operate? The choice is really up to you. Thanks so much for watching.